Do you want to talk about the watershed that we're in?
Okay, so we are in the, well, this is Republican, this is part of the Republican Valley. And to the south is Milford Lake.
Mm-hmm.
And so Milford has had a history of blue-green algae blooms. They actually have areas of the lake right now that are closed.
And so Milford Lake is an Army Corps of Engineer reservoir, but it's used heavily for recreation and fishing and boating and water supply. Yeah. So there's many uses other than just flood mitigation.
Well, it's a high-value recreational lake. You know, you have Manhattan, you have Junction City, and the surrounding communities that mm-hmm. use it for recreation. And when they close the lake because of blue-green algae, then it becomes a no-contact situation.
Yeah.
And so they want people to avoid direct contact on the lake right now.
Right now?
Yes.
I didn't realize it was, oh, okay, interesting. I didn't see that on the news.
So warning for the lake right now.
Yeah. And one of those sources is phosphorus bound to sediment like you're seeing in the H flume there. So. And
I did show, I know, I try to keep this concrete pad shoveled out so that it doesn't accumulate sediment. And one thing we didn't, so we don't have it set up for sediment trap. You know, that wasn't part of the treatment mm-hmm. Design for this particular experiment. And this is something that NRCS normally doesn't do.
Yeah. So NRCS is a technical government agency, which means they provide technical support to farmers and give recommendations and help prescribe and implement conservation practices. But in this case, you guys are looking at dynamic soil properties, which are relevant to the soil survey. And so, so this funding, so my understanding is that it's coming from soil survey or the soil plant science division, correct?
Okay, so the funding for the dynamic soil properties and the soil moisture sensors are coming from soil survey.
Okay.
The flumes and the runoff analysis, basically anything that's impacting the use of the flumes and the runoff are paid for through the National Watershed Division. Okay. They have funds every year that can be used to install systems like this.
Interesting. Okay.
The year that Ron applied for this one, he was the only person in the United States that did that. Mm-hmm. And I think, if I remember right, it's about $320,000 mm-hmm. that NRCS they're investing over the 9-year period.
Which for a long-term experiment is actually relatively inexpensive.
Yes. Well, you know, I'm cheap.
Yeah. Yeah. So I should mention that Tom is the former state agronomist for Kansas with the NRCS, and he's retired, and you're consulting on this project.
Yes, and it's been just so highly educational for me.
Yeah.
Especially the soil moisture part of it. You know, it's something that as an agronomist, you know, you always were concerned about, well, do we have enough water for the crop? Mm-hmm. But being able to see how those readings change at different depths and how fast they can change, has been an eye-opener for me. I had never really given it a whole lot of thought. Mm-hmm. And so it's interesting to see as the plant grows, you know, how those the volumetric water content changes at different depths.
Yeah. And you could basically track with the depths you guys have the sensors installed at. You can basically see to what depth the root systems are.
Yeah, and well, that's right now. That's where it's really interesting because right now 50 meters seems to be getting hammered really hard.
Yeah.
Or 50 centimeters. I'm sorry, not 50 meters. 50 centimeters is 20, 30, and 50 are getting pulled real hard right now.
Mm-hmm. And most plants will put most of their roots in the top 50 centimeters, whether that be prairie grass or row crops. But yeah, they'll start extending deeper as things start to dry out, and they're looking for resources and water in particular. So.
And okay, so yeah, another thing to talk is our cropping sequence out here. So last year this was grain sorghum. It's soybeans this year. Once the soybeans come off, it'll go to wheat. And once the wheat's harvested, it'll be double crop back to soybeans.
Okay.
So that's the rotate, and then it just flips and goes again through the period of the study.
And then you mentioned this top watershed. You're going to have a winter cereal cover crop, right?
Well, Ron's going to, I mean, we're probably just going to use wheat.
Yeah,
It's easy to get. It grows well. If you're ever going to have wheat out here, soy or rye may not be the best thing to plant.
Yeah.
I rogued enough rye as a kid. I don't.
Yeah. And so you're going to put the wheat cover crop on after sorghum? Is that the part of the rotation where it's going to go?
It'll be planted every year.
Okay. Yeah.
Every year it's not planted to wheat.
Okay.
Well, and he has the option based on the soil moisture levels to either plant grain sorghum or corn.
Mm-hmm.
Because the nutrient requirements are similar.
Yeah.
And so we wanted to give him that flexibility. You know, if he goes in and the nice thing about it is we'll know what kind of profile moisture levels he's got.
Mm-hmm.
And he can make that decision what kind of warm season grass crop he wants to plant, whether it's grain, sorghum, or corn.
That'll definitely be handy for him to actually have the hard data on what his moisture condition is looking like. So that'll be good. And
again, you know, what soil properties would we be looking at? Well, I can think bulk density, aggregate stability, KSAT, you know, saturated hydraulic conductivity. Those parameters that track how water moves through the soil profile. Nice thing about this one, I think we can come up with a pretty good water budget for the entire field.
Yeah, because you have all the measurements that you need for evapotranspiration right there. So,
and we're looking at it's Anders Patrangani's lab. I think it's called the Soil Water Lab.
Yep.
They've got some. You can upload your data to the Soil Water Lab, and they have a program that will figure your evapotranspiration.
Oh, so it's like a web app for calculating ET, huh? Interesting. Yeah. So the landowner or the manager here, what's his goal out of all this?
He wants to know what's coming off the field. That's what he's interested in finding out. Mm-hmm. Is based on his management, how much phosphorus is leaving the field.
All right.
That's what he's interested in finding out.
Well, that'd be useful information, especially in a
in a paired
phosphorus and paired watershed.
It's a lot of, that's a good thing to know. And as we progress through the rotation and data collection, we want to be able to share that information with people. Mm-hmm. We do plan on having some field days out here so that we can kind of talk about, okay, what have we seen so far? Mm-hmm. Obviously, last summer and this winter and even this spring, we didn't have a lot of runoff events. Mm-hmm. And so a person has to be cautious about making any conclusions when you've got a limited amount of data.
Yeah. And that's definitely a strength of a long-term study is at the end you'll have 9 years. So,
when they first told us, we we're working with the Watershed Division, and they're out in Portland, Oregon. And so they also do snow survey and some other things out that's where that information's goes to. And their point was, we told them what his crop rotation was, and they said, well, okay, we have to change something, so you're going to have to add a crop. And initially he was in a 2-year rotation, and then adding wheat took it to 3. And then you have 2 rotations of that 3-year rotation where the treatments have been imposed.
All right.
So we're kind of hoping we get into a wet cycle for the next 7 years.
I think every farmer wishes that, at least in Kansas.
Well, and I think we've been pretty lucky up here in this area. Things were starting to get a little stressed last week. But we had a little over 2 inches of rain and very little runoff.
And I think the interesting part too is with the dynamic soil properties. I mean, the properties you guys are measuring all have direct influence on how water infiltrates and is stored and is used by the crop, and through all the other components of evapotranspiration. So it'll be interesting to see how all those properties, how they change over time, for one thing, through different management changes, like adding wheat, for example, or changing phosphorus.
Well, phosphorus placement, placement, and I think the sufficiency one, I think, are going to be the interesting ones.
Yeah.
He does harvest each watershed individually. They've got scales on their grain cart.
Okay.
And so they know the watershed area, so they harvest that area, and then they measure the weight off of their scales on their grain cart.
Okay. So for the 4 phosphorus treatments, so you mentioned there was the status quo, right, basically, and then you have so sufficiency means you're essentially applying based on current Kansas recommendations that once the soil gets down to 20 parts per million for a soil test, and then build and maintain is like 40 ppm plus.
Well, build and maintain, so sufficiency actually could be lower than that. Build and maintain, you build, well, and those are all going to be changing here shortly. I think the soil fertility folks at Kansas State have been doing a lot of work.
Yeah.
So their nitrogen recommendation is going to be changing for corn. They've been doing some work on phosphorus, and I think they're also doing some work with potassium. So all of the recommendations, with the exception of the bottom one, Terrace, which is farmer practice, will utilize the K-State soil fertility recommendations for the pertinent crop that's growing out there.
And so for all those, is it going to be applied as broadcast, with one treatment being like injected for placement? Is that kind of what you're thinking?
Yeah. So we're going to have one where we're going to do injection, and then the others will be broadcast.
Okay. And in Kansas, I think by and large, most people do broadcast.
That's the dominant.
I think the one exception is if they're doing strip tillage, and then they inject at the time of strip tillage.
Yeah. Well, and for a lot of guys, putting on, their farms have gotten bigger and bigger and bigger. And planting is, if you are having to stop and refill the tender or whatever storage vessel you have for your phosphorus, that slows down your planting speed.
Yeah.
And so, and you know, it's depending on how big your tank is for your fertilizer. You know, it's a horsepower consideration that I think you have to look at. And so, but the interesting one to me is going to be the sufficiency one, I think.
Yeah. See the phosphorus get drawn down presumably over time, and
well, and that's, you know, it's the question is, will we draw it down fast enough over the life of the experiment to actually apply anything?
Yeah. Yeah.
That's to me going to be the interesting part of it.
I mean, that alone is kind of useful too, because yeah, if a farmer reads the results of this study and they too have, say, high phosphorus to begin with, then it might mean they don't need to pay for phosphorus for a while.
It could be. I just got, you know, it's going to be interesting to see how things change over time. That's what I think is going to be interesting.
Yeah. And going back to broadcast, so I'll mention for students that aren't familiar. So broadcast applications of phosphorus is also the predominant means in Kansas, but it's also like the most common means of phosphorus application in no-till, just because like you're not tilling things up, and so it's hard to incorporate phosphorus.
Well, and that's where you get into, you know, you basically pull some type of nurse tank, or you have tanks on the planter, and so you're having to stop and refill. You know, making sure that your application equipment, everything's set up so that it goes down in the soil, that gets to the correct depth. And it's one of those things where it's a time-consuming way to apply phosphorus. And so the other thing is that this field is grid sampled, and so he's been applying everything using precision application techniques. They actually have their own spreader truck, and even their nitrogen sources they use Encirca, which is a subscription service that is how they do their nitrogen application.
Okay. And for grid sampling, related to that, you were mentioning earlier that this is a crete that has a predominant soil.
Silt loam. It's crete, silty clay loam.
Yeah, so it's a mall soil with very heavy clay argillic horizon.
It's dense.
Yeah.
That time-lapse camera you saw earlier, I worked on it Thursday and Friday of this week, and after I chipped a little hole with a spade, I just started pouring water into the hole, and got it about 10 inches deep Thursday, and then filled that hole up and just let it infiltrate overnight, and then came out the next day and got it about another 3 or 4 inches deep, and then just hammered those, used a T-post driver and hammered those metal conduits into the soil.
Yeah.
So when it gets dry, it gets pretty dense.
Yeah.
And you can, if you look up along the field edge, you'll see where the cracks were and how they've kind of, with this 2-inch rain, have kind of formed back together.
And you were mentioning that it must have been so cracked that you actually saw the biggest response in soil moisture in the bottom depths first?
Well, it was on that, about that 50 where it seemed to pop.
Yeah. So it's like water's running down to the cracks first, and then as things swell up, then you get...
Well, and again, so when they installed, it was so dry when those sensors got installed that it was just cloddy. You know, there was a lot of air voids, and I'm not so sure that that's... I guess I'd be a little cautious about using stuff from this year.
Yep.
I think you better, it's better now that we've had some rain on it and it's kind of,
Settled a bit.
expanding and contracting and settling, so that we can see what it's going to be like going forward.